we've got another problem where we've got parametric equations as follows, and in this question we are required to produce a Cartesian equation that looks like this. It's the sort of question where they've told you what you're supposed to get. That is the answer we're supposed to arrive at by converting this parametric equation into a Cartesian equation. This question was 6 marks. So if you think about where this is on the scale, a standard, perhaps easy, you might call parametric equation question to Cartesian would be 3 marks. Something a little bit more challenging would be 4, perhaps 5. 6 marks is quite rare. That means there's quite a lot to do here. So let's get cracking. So the first thing we want to do is isolate the trigonometric functions without any coefficients or any other terms. So I just want the cos t, so that 2 needs to go. So we'll do x over 2 is cos t. And here there are no coefficients or any other terms, so that can stay as it is. Now, when you have to relate two functions, where one of the functions is sine of a plus b, or a minus b, or cos of a plus b, or cos of a minus b, there's only one way to go. We expand this out, and at some point in the expansion we're going to get cos t involved. So then we'll insert that x over 2 as it appears. So let's expand out sine of t minus pi over 6. Remember, sine of a minus b is one of those expansion formulae that you actually get in the formula book. However, I do recommend you know how to expand this yourself quickly without having to refer to the formula book. So let's expand this out. So sine of t minus pi by 6 would be sine t cos pi by 6 minus cos t sine pi by 6. What we should do now is recognise that cos pi by 6 and sine pi by 6 are numerical values that you could, if you wanted to, use your calculator, but they're reasonably familiar values that hopefully we realise what they are. So sine t, I'll just write sine t here, multiplied by cos pi by 6, which is root 3 over 2, minus cos t, and sine pi by 6 is 1/2. Now, sine t minus pi by 6 therefore becomes this expression here. I could replace that with y. I can replace cos t with x over 2. So the only term with t left in it is sine t. And we've seen in previous examples, if you need to eliminate sine or cos, but you have the other one, you use sine squared plus cos squared is 1. So eliminating sine t is not a problem because I've got cos. And therefore, if I've got cos, I can use cos squared plus sine squared is 1 to eliminate that. Okay, so we established sine t minus pi by 6 is this expression here. The next thing to do is cos t, we said was x over 2. So that becomes 1/2 multiplied by x over 2. So that term is now free of t, which is good. Sine t we haven't got just yet, so I'll just leave it like that. Sine t minus pi over 6 is just y. And like I mentioned, to get sine, and we have cos, we use sine squared plus cos squared is 1. So I'll park that there, and we'll just use sine squared plus cos squared is 1. We established earlier that cos is x over 2, which means that's x squared over 4. And sine squared t I'll just leave as it is because we're looking for sine t. That means that sine squared t is 1 minus x squared over 4. At this point here, it's worthwhile to combine these two terms together. Write that as 4 over 4. I'll go up here, which means sine squared t is 4 minus x squared over 4. And that means that sine t, if if you square root this and then square root top and bottom here, that's the square root of 4 minus x squared divided by the square root of 4, which is 2. Now what we'll do is we'll insert this whole expression in there, and by extension there. So, if we just tidy that up, we should arrive at the answer we're supposed to get. So let's see. Right, so we said sine t is root 4 minus x squared all over 2. Let's insert that in here. So what do we get? We get y is root 3 over 2 multiplied by this. This we can easily simplify. 1 times x is x, 2 times 2 is 4. This also has a denominator of 4. And if you notice, when you multiply two surds, you should recall from GCSE that you can multiply the inside of those surds together and put it inside one big surd. So if you multiply the 3 and the 4 minus x squared, you get 12 minus 3x squared. Don't forget about the 2 and the 2 on the bottom. And then they both are divided by 4, so you could write it as one big fraction all divided by 4, but you can see the actual answer they want, they've actually taken out a factor of 4, which effectively is the same thing. So if we take out a factor of 4, what are we left with? This surd minus x, and great. That agrees with the result we were supposed to get, and that's a very nice 6 marks to get if this were to come up in an exam.